This is the information in your daily life. Then our goal is what? Build a database. Where? On your computer, not on the backpack, not on your brain. It's on your computer. That's the difference. If we keep the database on your brain, I don't have to learn the database design code. You can just keep asking. I just keep asking you to keep this information until you memorize all the things. Okay? Unfortunately, computer cannot understand your order. Computer can understand only design or structured information in their system. So, our goal is to build a database from information to computer. So we will learn step by step how to do that. Okay? Also, however, even though you do not know the details of the step, but you probably heard about the data and database, collection of the data. What is the database? Why do you need a database? Let me change the question.
To analyze data. To analyze data.
Analyze the data? Store the data. Okay, because we have huge amount of data, it's very hard to keep or to manage the data. Okay, so we need a database. And what else? Why do you need to manage? Do you want to manage the or store the data which are not useful? No, you want to use such a data. Okay, so let's say we have the 10 millions of the information about the customer. 10 millions. So we have the customer database 10 millions. But from time to time we need to find the information about specific user, specific customer from the 10 million. How can you search the data? If data are not organized, it will take forever. 10 million, so how long it takes to search all the 10 million data. So our goal of the database actually to search the data. That's our final goal. If there's a way to search the data and without the database, yes, we can do that. You don't have to manage it automatically. For example, he's a genius. He can control the 10 millions of the personal information. Then instead of using computer, I can ask him just to memorize and such. I need the information about the Professor Lee that he can do that. Unfortunately, human being cannot do that. Instead, we like borrow the ability of the computer, especially the database, to search the data. Okay? I know there are controversial. What is the main goal of the databases? Somebody said because data is important, we need to manage. Okay? We need to keep. We need to security. We need to do something. But the most important is eventually we need to access the data very fast. Search the data very fast. That is our ultimate goal. To do that, the data should be well organized, structured. Okay? So that structure, data means, in other words, modeling. Modeling means, what's the model? You probably learned about a lot of time modeling, programming modeling, something modeling. Why don't you model this project? Something like that. What is the modeling? Modeling is you create the rule and constraint and condition. Okay? Then your modeling tool, modeling algorithm, something modeling is a collection of such a constraint, such a rule, such a policy. So, especially to design, to organize such information into the database, we need something specific modeling. For example, in the programming model, what is the most popular model nowadays. Object-oriented modeling. We consider data as a data structure as object. Using that object concept, object modeling, we can do variety of the thing. Similarly, in the database, there are a bunch of the different rules, different modeling techniques. One is a hierarchical model. We consider data as a hierarchy, like a family tree. Another way is we consider data as network, because they are connected. In this class, we are going to use one of the modeling technique, database modeling technique, that is called relational database model. So relational database model, when we are saying the relational database is a name of modeling. So one of the ways to organize the data, is that the only way to organize the data? No, definitely not. There are a bunch of different modeling techniques. Then, have you ever heard about the relational database or relation or any R something before? If not, that's the problem. You should have heard. I believe you heard about the RD or the R modeling, relational modeling. Are you interested to get a job after graduation? Yes, definitely. So you probably from time to time when you are boring or when you are tired to complete the homework, you search the job. Which one will be my dream job? Something like that. At that time, many of the database related job description mention about the relational modeling. And specifically, sometimes it's called the conceptual modeling, something other modeling, but that are related to relational modeling. At that time, what is the relation? What does that mean?
Connection.
Connection?
Between data.
Data?
Relation between two tables in terms of
Relation
primary.
between two tables? It's not a mistake, but actually, the name of a relation comes from relation. Relation actually comes from
Relation between
set. Have you ever heard about the set? Set theory. I believe so. The problem is you cannot remember. Why don't you go back to your elementary school math class? You probably learned 1, 2, 3 as a group. This is called set A, n element. Okay? Another way to represent the set of elements is x bar. X is bigger than 0 and x is a natural number, something like that. This is a set. What is a set? It's a group of elements. So we consider data as element. Then grouping. If data are related, okay, like this is student 1, student 2, student 3, we group as a student relation. So relation is the same name as a set. So we borrow the idea of a set in math to organize, to model the data. That is called relational database model. This idea was proposed by Dr. E.F. Cole at IBM 1969. 1969 is one of the important year. What happened? 1969.
Except for the
So Neil Armstrong, 7 on the moon, first time. Okay, there is another important event happened. On April, Professor Lee was born. And also Dr. E.F. Cole proposed the first time the idea of how to organize big data, very large data. Then, what if we have a small amount of the data? We will discuss a little bit later. So, when we have the very large data, traditional model cannot handle such a thing. In other words, it's very hard to find the data, specific data from traditional data-based model. So, relational database model. So he got the idea of the set, then proposed the relational model. Then this is the relational model. Then we have the idea, no matter how we organize the information to database, we have something. We will learn throughout the semester this one, but we have something model. Then eventually we need to create the database on a computer. Okay? How can you create the database in a computer? We need what? Software, application program. If you have the idea of something website, you should have the application program to develop your idea, like the .NET program language. Okay? If you want to create the novel, so you should have the application program for word processing. And similarly, to create the database, we need the database software. That is called Database Management System, DBMS. If this software is based on relational model, it's called RDBMS, Relational Database Management System. If this is based on the object-oriented model, this is called ODBMS. It's a software. So, example of RDBMS include what? Sample of RDBMS. Oracle. DB2. SQL Server. How many? At least several hundred of relational database management system. Even in this class, we create the classroom RDBMS several years ago. As long as this software follows this rule, it's okay. It's considered as the relational database management system. Okay? So, this is like the other application program. So, for example, Office. Office tool is the application program that can have office work, include PowerPoint, MS Word, other open office. They are the example. Similarly, Oracle is not the database itself. Oracle is nothing but one of the example of software. So do not say, I'm the expertise in Oracle, so I'm the expertise in the database. No. Your expertise on just one of the programs. Can you say I'm the expertise of MS Word? Sometimes when you got the secretary job. Okay? That's it. So even though you know what you have used one time or two times of the DB2 or SQL Server, that doesn't mean that you are the expertise on database. We will learn throughout the semester this part. But to implement your idea as a database, we will use one of these. You can use any of them. Yes, they are different, actually. Even though all of them are following same model, a little bit different. There are benefits or the disadvantages. But among them, basically they are the exactly same concept because they follow the same modeling. We will use Oracle database. The only reason is because that is the most popular software. If you understand the Oracle database, then the others are almost the same. It's not a big deal. So you can easily catch up the other software. Okay? So, this is the missing part is count this time. Okay? So, this is the main purpose of the first half, almost 60%, the 2/3 of the semester from now. So, that is the designing part. Then, I mentioned about something idea of Dr. E.F. He actually proposed the relational model because of what? When we have very large data. Okay? So what if we have a small amount of data? do we still need the DBMS or not? Maybe? What about you?
Just for large amount.
So, in your use for your computer, are you using DBMS system or not? No. Why you don't use? Because the database, Professor Lee said a lot of benefits, something like that. Then why you do not use?
Have a large amount of information to store. I think just we need if we have a large information like government or hospitals or schools.
Then let me change the question. So you said that you are not using the DBMS. Then how do you manage your data?
Sometimes we use notebook.
Notebook.
Yeah.
Any other? Any other who are using the DBMS to manage your data? Base management system? I don't think so. Then how do you guys manage the data, your data, on your laptop or on your computer? Fine. Yes. So, alternative way of managing data is file system. Using file system versus DBMS. What is a file? What do you say file? Collection of data is data. What is a file? I do not say your answer is wrong, but not clear. What is a file? Did you take the operating system class? No? It's mandatory. It's a core course for computer science and engineering, right? Nobody too? This semester you are taking?
Yes.
So, except you. So what is a file? Container? Yes, close. It's kind of container, yes.
Organized data structure.
Yes, it's a data structure. For what? To keep the data. So same thing, same idea of the database. Okay? But it has a file header, then it's a sequence of just a bit string. Okay? But they are organized. Sometimes it has a new line character, it has a format, it has something. Okay? And each of them is based on the ASCII code to represent, for example, when you are using the notepad to write your diary. So I am a student, I will read something ASCII code and convert it into the binary. Then it's a sequence of the data. Nothing but sequence of the data. Then it's organized. It's a data structure. Then you can keep your data information into that file. Then you have probably a bunch of files, like a bunch of the data, collection of database. How can you manage such a bunch of files? File system. What is a file system? File system, yes, data structure. You can use my lecture. File system is the data structure for what? It's a software to manage such a bunch of files. Okay? UFS, Unix file system. NTFS, FAT32. What else? There are a bunch of the NFS, Network File System. There are a bunch of file systems. Some of them are free, some of them are not. You need to pay. Just like the DBMS. Then this one is most of the student in this room use file system instead of this one. Why? Expensive. Hard to run? Yes, that's one of the reasons. Slow. DBMS is slow. Why? Professor Lee already mentioned about the main reason of using database is speed up to find the data, search the data. That's the most important reason. Then, this makes sense. File system is faster.
For big data,
Yes. When you have just a file, for example, I recommend it's LEE, Professor Lee's last name. If you are using file system, you can create a notepad. use this one. Then if you want to access this data, you can open the file using the application or in your program, like the C program, main, and F open the file name and read the data, F read, then you can get the data, right? Then this data will be managed on memory. Why is memory? What? This might be the program, right? What is the program? What is the process? Data structure running on memory is called the process. Program is a data structure including sequence of instruction. Okay? So you can read the data, manage the data on the memory. It's called the memory-based data management. Most of application is memory-based. There is no application program, there is no computer program without data. All of them have the data. Okay? Even though you create a hello world simple program, that has the data, hello world. Okay? So, at that time you can manage the data using memory without DBMS. However, if you manage the LEE, Professor Lee's last name, using the DBMS, you need to first install DBMS Oracle. Design. Create the something that is called a table. You don't have to worry about it if you do not understand. Then insert this one. Then from database language, like the SQL that we are going to learn, you need to access this, go through the DBMS, and you get the permission and return data. It will take much longer time than file-based system. When we have the small amount of data. However, the story is changed if you have 10 millions of the name of customer. I need to find the lead among the 10 millions. How can you find? You need to open the file, read from the beginning until you find this one. If you are lucky, you can get the first time. Otherwise, you need to go through all the way to the end of the file. The brute force way. So, it will take much longer time than this. What? This one is something structure and rule. Organize data to access the data very fast. We will learn this. It's not clear how DBMS supports such a fast accessing when we have the huge amount of data. It's clear when we have just simple data, it's slow. How can we? There are two main ways to speed up very large database. One is what? First,
Establish the relation between the data. Establish the relation between the data.
that relation does not guarantee speed up. The more data you have, the higher complexity. And
Related information.
we will learn that later, but the answer is, the first reason is,
Insertion in parallel.
before parallel. Parallel is additional approach. Add more and what kind of resource?
Memories.
Memory.
Processing power.
Only memory. So given as a purely rely on the size of the memory. Cache. That time we can go back to the Von-Neumann data computer architecture. The core part of the Von-Neumann data computer architecture is what? Cache, memory. Okay? Even this, for example, instead of accessing hard disk drive, you can access the memory. That's much faster. Okay? So DBMS actually require more resources as he answered, especially the memory side. For example, when you install the Oracle, you can download it freely from the OTN, the Oracle, whatever. But when you install the Oracle, it requires minimum 2 gig, 4 gig memory size. Okay? What about this? You don't need the memory size that keep only your program. 64K depends on your operating system, 32K. Another way is anyone who has a textbook, any kind of textbook. Nobody has no textbook, any textbook. Any book. I believe that you are using the electric version of that. For example, let's say that this is a textbook. When I ask you to research on the specific term, like the why don't you research on the database? How can you find the database, terminology of database? You can use index. What's the index? Most of the textbooks provide the index at the end of the textbook. You can search the data very fast because it's organized. It's sorted by keyword. Database provides exactly 99.999% same idea, algorithm as the index in your textbook in their database to speed up search the data. Okay, that's called the B plus 3 index or B3 index. In your second project, you will implement this B3 index. So because of that reason, you can manage and search the data, very large data, fast using given. Otherwise, you don't have it. Just like the laptop computer, you don't have to use this one. So that's the difference. So for this database, so this slide shows the database system environment. Sometimes without DBMS we can manage the data, but we are going to use design and implement the database. Then eventually from your application we will access the data. Okay. Our goal is to build a database like this. Okay? Don't worry about even though you do not understand what that is. For example, from the university, okay? I'd like to build a university database system or something university system. We need to manage the data from the university. At that time, no matter what method you use, you organize the information as a data like the student, course section, grade report, and prerequisite. And student consists of the name, student number, class, major. Okay? That's our goal in this. If you can do such a database design, that's all in this class. Also, in addition to design of such information and data, eventually we will manage the data that fit to the design of your database. So this is called overall database schema. You probably heard about the schema. In this term, schema means what? Description. So if I ask you, why don't you design the university database schema? You will find you need to design something description that describes your university database. So this is a database schema. And then this is the instances, sample data. Our final goal is design the database schema and create the instances that is called database state. So our final goal is to create a database state. Then the application program or user can access such a database state. Okay? So this is the characteristic. Some of them I already explained, and the others are not. I'm going to quickly go through the main characteristic of the database approach. First one is the self-describing nature. Is there anyone who heard about the self-describing nature of something, whatever? What is the self-describing nature?
Means it's described, it
itself, by itself.
Yes, describing by itself. That why? That is the characteristic. Why?
Very easily apparent just from the name or from looking at it.
Yes. In other words, for example, this is a good example. When you access the data based on file system, you can open the file, open this file name. You should know data structure of this, but you don't know. So you need to implement in your program. Like the first 10 byte, or until you got the special character, it is the last name. And next, you need to design in your program. Right? However, if we are using the database, because this describe itself, it has all the definition about your data, like the name. Database know where the name is located, how many bytes it takes. So you don't have to, in your program, you don't have to worry about it, just code name. Then DBMS search such a name. Data needs somewhere in your database. Because all information are stored at your database, especially database format. There's such a description. Metadata is a database format. It's another database. That's the reason it's called a catalog database, which is not in file system. Sometimes file system use indexing to speed. That cannot be the database structure. It's just the cache information about the file. But DBMS provides such a self-describing nature. In other words, it has another database to describe all the database in your database system. Okay? So especially the relational database model, it's easy to access such a metadata or catalog data because it's a database. You will learn later the SQL language that allow user to access data very easily. You can use such a same SQL language to access the catalog information. Also, catalog database include bunch of useful system information also. Okay? What's the size, current size? What's the usage of your database? And what is the main process running on your system? Something like that. Because of this, the self-describing nature, for example, what if I define the first 3 bytes as the last name? I change the name as a list. You need to change the program, right? And compile and run it again. However, if you are using database, doesn't matter. Change this DBMS inside control everything. So in your program, you don't have to worry about it. You don't have to change anything. Just code name, same name. That is called insulation between program and data. In terms of the program point of view, don't care inside of the DBMS. No matter what happens. Just ask the name using the database model. Who is in charge of? DBMS system in charge of everything in the database. So that is the insulation between program and data. Also, database system, in both file system and DBMS system, you eventually store the data in your hard disk drive. Okay? And this is also hard disk drive. Okay. When you store the data, you need to specify the directory or folder or file type. So if you are using the Notepad, it should be TXT file. If you are using Microsoft Word, it should be the DOC file, DOCX file, something like that. So you just should invite to store such a data. Some part of the information can be managed by file system, but not always. So, however, when you are using the DBMS, I'd like to insert the data. I'd like to create the database. You don't care where the data is located. How data are saved. Who is in charge of such a DBMS system? DBMS system will control everything that is called data abstraction. Okay? So we will see the little bit details about the data abstraction. There are two levels of the data abstraction. One is a logical level, and another one is a physical level. Okay? Logical level means so we have information like the last name. So this is the information. So we design this one as the name. Okay? This is called database schema. Okay? This is the instances. So it's a database state. So this time name is, for example, character 10 byte. I define such a way. So, however, then in your application program, you can access this data as the name. Not exactly the such a way. We will learn details of the syntax. Just don't pay attention too much the rule or the syntax of this one. Okay? And in your application program, you want to access the name like this way. For example, this is too small, so I change it 10 to 12. Okay? So, however, in your program, you don't have to worry about. You don't have to change it. It's a program data independence. It's also logically independent. It's a logically data abstract. How? Okay? In your program side, it's an abstracting. So that is called the data abstraction, especially logical abstraction. Also, when you insert this data into your hard disk drive, who is in charge of? DBMS. Know how to store Lee or Parker or Clinton, something like that. This is called physical data abstraction. Physical level data independent. Okay? So DBMS provide the data abstraction, two levels of the data abstraction. So that's the benefit. Another benefit of the DBMS is I have the student. Instead, that includes the name, ID, and address. For payroll office, let's add one more SSN. Payroll office is interested in social security, right? And also, what about your academic advisor? Academic advisor is interested in the ID. Mailroom office is interested in the address. It's all different. How can you create such a data to support all different departments using file system? You need to create a different file. Student file for mail, student file for HR, student file for advisor, student file for payroll office. It's all different, but they are not actually same. But if you are using only one file, payroll office can access all student information. Mail office can access all the information. So you need to separate such a file. However, if you are using the DBMS, HR office can access only part of student. Payroll office access ID and social security. How can you implement? You can create few data structure. DBMS supports such a virtual the data structure DBMS. That is support of the multiple view of the data. Physically, how many data? Only one data. However, it can be viewed as different way. Okay? That is another benefit, characteristic of the data. Also, database support multi-user transaction. Long time ago, SQL Server. Basically, Microsoft product is based on single user system. MS-DOS and Windows 3.1, Windows 95. Still, Windows 7, Windows 8, even though they support the remote access multi-user, major priority to use the Microsoft product is personal system. That's different from the Unix or Linux system. So database was the same. When SQL Server was released the first time, it's only for single user system. It's simple. Why is it simple? We don't have to worry about the lot of the data. For example, when you have the data but multiple user A and B, A is modifying this data. B is modifying the data. Can B access the data? No. In single user system, doesn't allow because it's locked. Just like the Windows system, if you open the file, you cannot reopen the file for writing. It's only for read only. That's a single user. However, DBMS support multi-user system is provide different transaction control. So we will discuss about such a concurrent user system in the second half of the semester. So we have discussed about the benefit, advantage of the database approach. Okay? So the problem is that the only solution to manage the data? DBMS is always good for managing data. That was your homework, right? Did you do your homework? You can say just yes because I cannot open your brain. I didn't ask you to submit anything. Just thought about it, even though you didn't thought about this idea, but we already discussed about it. When it's not a good choice? When you have small amount of data. How much small? It's up to you. That's the job of your, after you graduate, if your boss asks, I think he thinks that we need a database system. Why don't you research on such a database? Then at the time, you can suggest we don't need database system. Instead, we can cover. How can you cover business logic? In your program. In your program, manually you manage your own data, like the picture, photo that you have taken. How can you manage? You organize, you classify. Such a way you can manage your data if you have a very small amount of data. Also, relatively non-important data. If you have very, very important data, if you lose such a data, entire world will be demolished. Then you better have the DBMS for security purpose. Okay. Also, depending on the business purpose. Okay. For example, banking system is critical for transaction, and stock market system is very critical. When even 0.1 second difference between he and me, I can earn the money, but he can lose the money. But if you don't care such a time or the multiple transaction, even though I try to buy the stock, Microsoft, the stock, but the system allow him to access the data, then that's not fair. So it depends. But mostly is the system. Your data is not big and also relatively not important. You'd better keep the fine system. In other words, in your program level, you can manage. Just like the project. Actually, in most of your project, in your algorithm class, did you use the DBMS? Nobody used. Instead, how can you manage the data. Like the integer I is equal to 0, integer j is equal to 10. In your program, memory-based data management, you can do that. Okay? Also, budget, money. If you decide to go for the DBMS approach, you need to purchase the DBMS Oracle. How much expensive? Very, very expensive. Okay? It depends on the number of processors. They charge the money. 1 copy, 2 copy, no. There's no concept of 1 copy, 2 copy nowadays. Instead, if your system has the 10 core multi-core system and the 10 CPU, they charge it based on that. Okay? And also, every year you need to pay maintenance. It's a 20 to 25% of your purchasing cost. Very expensive. Actually, the most of such a IT company make the revenue and profit from the maintenance. Okay? This is very expensive. Another problem is user administrator who can manage the database. If database itself is nowadays is very easier. Last year, in big company, they need database administrator who can manage the database only, like the Unix administrator. Is it easy to hire? No, even not easy. And is it cheap? Their payroll is very, very high. At least 5 digits. So I think the 5, 6, I think 150 the K for senior level administrators. Sometimes I got asked why right here instead of getting a job outside. I was a database administrator for 7 years. It's from the 96. It was kind of the early level of the database. So I have experience on the Oracle 6 from the 6, 7, 8, 9. And I have used the DB2 when I was in IBM. But the problem is, most of the database administrator job is not the daytime, it's after business hour, which means most of the jobs should start the midnight and should be completed before system opening. Very, very stressful, really. And also, my wife and my family almost tried to kill me because I should leave every time. And also, there is a system operator, but they do not have any responsibility. They just call whenever there is a problem. Just call and something problem. That was the reason my house was next to my office, actually. So just 1 mile away. So that is actually main reason why I quit the job and moved to United States to find a different way of life. But sometimes I miss because it's a high pay, that's true. But it's very hard to get the job entry level of system administrator. Almost no chance. Instead, you can start your job as a developer or database, the data developer or the software engineer in your project. So for example, you build the database system in the People's Bank, and if they believe you can manage such a system, then they hire. As a junior level, then you will perform something like that. Anyway, so that is the DBMS. Oh, one more thing. I forgot to this one. So this is a diagram that we are going to travel throughout the semester. So this week we are in the introductory part. Then the yellow box indicate the database design. So 450 topics in the 450. The others are advanced database topics. So 60% up to the mid 10, we will cover the yellow part, the database programming, then followed by the other. I know some of the undergraduate student is not required based on curriculum, but it's required to pass this course. Okay, but also it's a good opportunity for undergraduate student to learn about such advanced database topic. Okay. As I said, project A should be done by all, both undergraduate and graduate, and project B, implementing B3 index, is only for the graduate student. But for undergraduate student, project B is optional. If you complete it, you will get the extra point. Also, for undergraduate student, it can be the group project by up to 2, but it can be also the individual project. But graduate student is purely the individual project. So what is a data model? Data model is a structure. We are going to build such a structure. So data model is a group of such a